Welcome to the final MQ session for today, session 1AW. If you would remember to fill in the feedback form after the presentation, it would help us a lot. Please post queries and questions on the chat room, and I'll let Todd know if any appear, if he can't see them himself. And without further ado, I'll hand over to Todd.
Well, thank you very much, Mel. Welcome to this session. Imagine how much you can learn exploring MQ statistics and accounting data. My name is Todd Havicost from IntelliMagic, and I appreciate the opportunity to participate again in this year's GSE UK conference. Last year, my colleague John Baker and I remarked to one another that we felt the quality of the content offered here was exceeded really pretty much the other Z conferences. And from looking at this year's agenda, I expect a similar outcome. An interesting story on this time slot. When Mel asked my preference, originally I asked for an afternoon slot that would work with my normal US location, which is 6 hours earlier than UK time. But in the meantime, as luck would have it, I ended up being in Europe this week in advance of a tour that Frank Kine and I are going to be going on next week, where we'll be presenting in Zurich and Germany and Paris. So really any time slot would have worked, but as luck would have it, this session ended up being scheduled at the same time that Frank Kine is presenting his ZED Roadshow session, which is typically a very popular conference. So I imagine many people are watching Frank's session live, and hopefully we'll then have an opportunity to catch this one on demand. But thank you for those of you that have joined today. And in any case, I hope you find this material as interesting as I do. Mel was just talking about things he enjoys doing in retirement. I have the great privilege of getting paid to spend almost all my time learning from and exploring all types of SMF data. And I'm a ZOS performance guy by background, but by virtue of having all these opportunities to learn from SMF data produced by MQ and DB2 and KICS and TCP/IP ZERT, I can now have intelligent conversations with folks in all those disciplines, due entirely to the great learning potential that comes from having good visibility into SMF data. So hope that's your experience as well. I hope you're learning new things every day from the SMF data in your shop, and hopefully not only in your own discipline, but also across other areas of the ZOS infrastructure. Okay, so the agenda for this session, we're going to begin with a brief discussion of the challenges that many sites face gaining value from their SMF data, the types of capabilities to be looking for to overcome those challenges. And then the bulk of the session will be learning journeys that are exploring MQ statistics and MQ accounting data. Now, many of you might recognize that quote, "See where the data leads us and what it teaches us." Martin Packer often says that in his sessions. I expect many of you have attended some of his sessions, perhaps even at this conference. I had the opportunity to attend 3 of Martin's sessions at the last large-scale in-person Europe TechU prior to COVID. And essentially his sessions all involved around applying that one idea, see where the data leads us and what it teaches us, to 3 different technology areas. For him, it was DDF performance, coupling facility performance, and CPU performance at the individual engine level. But when we have easy visibility into our SMF data, we can derive great value for learning and exploring, for analysis and problem determination, and enabling us to enhance availability through proactive prevention of problems. So the premise of this session is built on the great news that the Z platform produces an incredibly rich set of metrics, far superior to any other platform. But unfortunately, many sites face major challenges as they seek to realize that potential value. And those challenges include that the SMF data is primarily used in a reactive manner. Not until the postmortem following an outage is it discovered that a key metric had started showing signs of stress days before the outage actually occurred. Another challenge is siloed tooling across disciplines, each infrastructure team using capabilities unique to their area, specialized tooling that's difficult to learn and creates barriers to cross-team collaboration and learning. Another challenge is static reporting solutions because they require deciding in advance how you want to present the data with predefined views, fixed time frames, sets of variables, and scope of reporting. And changing a view typically requires a coding effort to create a new report. Another big challenge can be the ability to focus the analysis despite massive data volumes. Commonly here, well, we have so much MQ accounting data that finding what we want to see is like looking for a needle in a haystack. And in some cases, customers are so overwhelmed with the data volumes that they effectively give up and look for ways to reduce the volume of collected data or don't even collect the data at all. And then a final challenge mentioned that we hear from almost every site is declining expertise with retirements of tenured staff. The advanced skills required to analyze SMF data fields and write programs for new data types or to customize views are becoming increasingly scarce. And many of today's commonly used approaches involve significant barriers to learning for newer team members and steep learning curves required to use the tooling. So these are general obstacles that are applicable to all types of SMF data, but based on input from customers as well as conversations with attendees at MQ conferences, these areas appear to be particularly challenging for MQ. Despite the fact that MQ is widely used across today's ZOS environments, reporting capabilities for MQ SMF data have often lagged behind those of other aspects of the ZOS infrastructure due to factors including limitations of available tooling. Again, the idea that you have unfamiliar tooling that's siloed by area, and challenges arising from the fact that MQ has historically not received as much focus for in-house developed reporting. Another challenge is that generating MQ accounting data is often considered to be relatively expensive, both in terms of SMF record volumes and CPU overhead. And as a result, many sites don't generate the accounting data on a continuous basis. But these concerns may be overstated. In a recent blog, IBM's Lynn Elkins estimated the CPU cost of generating this data at 3 to 7%, which is lower than earlier numbers that had been published by IBM. And that may be very manageable since MQ is typically not a big CPU consumer in the first place. And in terms of file sizes, for one site that we worked with, their MQ accounting data was comparable in size to their KIX transaction data and less than a quarter the size of their DB2 accounting data. And that KIX and DB2 data is typically generated continuously at most sites. It's also possible that a lack of good visibility into this data is another factor that's influencing the hesitation to generate it. The sentiment being, even if we did collect the data, what would we do with it? But don't assume that MQ accounting data is collecting MQ accounting data is out of the question. A starting point could be to generate the data on a periodic basis, to establish a workload baseline, and also to measure your own SMF data volumes and CPU overhead, and then proceed from there. And I think that's a challenge worth taking on because, as you well know, MQ accounting data is typically relied upon very heavily by MQ performance specialists when they're investigating application problems and carrying out performance tuning. So let me suggest the types of capabilities to be on the lookout for as you seek to overcome those challenges and increase the value you derive from your SMF data. So getting out of react mode and into a position where you can leverage the SMF data proactively to prevent outages requires automated assessments of key metrics to identify potential risks to availability and performance. There's just too many metrics and too many components across the ZOS infrastructure to succeed at that task with a manual approach. overcoming the barrier of complex siloed tooling that's unique to each discipline can be achieved by utilizing a common integrated intuitive interface that gives visibility into many types of SMF data. And the advantage of that is then all teams have access to the insights provided by components across the entire Z platform. And that promotes collaboration and cross-learning. The limitations of having to anticipate in advance what data you want to see and how you want to see it, which are inherent in static reports, can be overcome by having the ability to dynamically interact with and navigate through your data based on findings from the current view. That provides far greater flexibility than working from a catalog of pre-generated static reports. And it also then allows you to identify alternative analytical paths based on the data that's currently displayed. And you can quickly investigate an alternative with a few clicks. And if you end up in a dead end, that's okay. It only costs you a few clicks and you can easily try another approach. Issues arising from massive SMF data volumes provide some of the biggest challenges facing analysts, but the ability to start from a variety of high-level views and then leverage context-sensitive drill downs to quickly focus the analysis on a desired subset of data is a powerful capability that enables effective analysis no matter how much data you're working with. And then finally, addressing declining expertise arising from retirements puts a premium on capabilities that expedite bringing newer staff up to speed, like intuitive visibility that removes barriers to entry and enables learning by exploring the data. And then also the interactive dialogues that enable ad hoc customization of reports that don't require making changes to programs. So these are capabilities to keep in mind as you seek to boost the value that you are deriving from your MQ SMF data. All right, so as you probably well know, two primary types of MQ SMF records, statistics and accounting. And those of you that are familiar with DB2 will recognize parallels to DB2 statistics and accounting data. The statistics records, SMF 115, provide data at the queue manager level, as well as by buffer pool where applicable. And these are lightweight records that have negligible CPU cost, and so they're typically generated on an ongoing basis. MQ generates the statistics data for each queue manager at user specified intervals. The default is 30 minutes. Of course, that can be changed. And then also specifying the stat end equals 0 causes the MQ records to be cut at the SMF global accounting interval, which facilitates collaborative analysis with other SMF data types because they're all dealing with the same intervals. And that's a recommended approach. MQ statistics data is produced by all key MQ components, including buffer manager, and we'll look at those metrics coming forward here in just a second. Log manager, we'll look at those metrics as well. Message manager, the rate of request by MQ command type. Storage manager, which with metrics including contractions and short on storage conditions. So we'll look at examples of these today. And then these other MQ components also produce statistics data as well in their areas. The statistics data also provides many metrics that lend themselves to being assessed as part of the overall health of a queue manager. The product that I'm involved with IntelliMagic Vision, we assess 30 such metrics based on industry best practices, which can be customized. And then views starting from a high level view by queue manager then can present these assessments in a consumable manner that directs your attention to potential issues that might warrant additional investigation. So some examples of metrics that lend themselves to being assessed are buffer pool utilizations and reaching right thresholds, weights for log buffers, checkpoint frequencies, and the storage manager metrics that I just mentioned. All right, so now in Martin Packer's words, let's see where the MQ statistics data leads us and what it teaches us. So I'm going to be using, of course, IntelliMagic Vision today as a tool to facilitate our learning journey, because interactively exploring actual data is much more interesting and easier to understand than just slides, and it also enables me to cover far more ground. So even if you're not a current customer of IntelliMagic Vision, this session will still show you many things you can learn from exploring MQ statistics and MQ accounting data, which then you can pursue with your data using your product of choice. All right, so let's go on over. Let's start with the area of assessments, assessing statistics metrics. So one area that's helpful for this is buffer pools, right? Just like DB2, MQ responsive performance for MQ relies on data residing in memory. So buffer pool management is an important aspect of MQ performance. And so that makes this a good area to be automatically assessing the metrics. MQ has a deferred write process that's activated when a buffer pool reaches 85% full. When that happens, that process will start to write the oldest data from the buffer pool out to disk to free up buffer pool pages for new messages that are coming in. And those asynchronous operations continue until the buffer pool utilization drops below 75%. So in that destaging, particularly undesirable for short-lived messages. And then also just to note, messages that have remained in a buffer pool for 3 checkpoint intervals will be written to disk no matter what the utilization of the pool. So in this example, we see exceptions for this high volume queue manager in a couple of areas. And so let's, because of course MQ, you got multiple buffer pools. Let's see which buffer pools the exceptions are. So here it's buffer pools 1 and 3. So if we go ahead and view those metrics at a glance, we see that for these first 4 metrics, we see high values around the 8 p.m. time frame. So let's go ahead and explore this one, which is the number of times hitting the deferred write threshold. So we can see that during these 15-minute intervals, that's happening many times. So again, we talked about that happening when you hit buffer pool utilizations at 85%. So let's go ahead and kind of bring those two together on the same chart to see that correlation. And indeed, the times when we're hitting the high deferred write thresholds, we're also hitting high buffer utilization as well. So that just is what we'd expect. So we're going to collect some key charts for along our learning journey here today. And we'll just collect those in a dashboard. So I'm going to create a new dashboard here. And MQ statistics. And then when we get to the end, we'll briefly review those just as a reminder of where we went today. All right, and we could, of course, compare it to any of the other metrics. If we look at the get page metric, we're going to see the same thing. That it's spiking up right at the time when we're hitting all those deferred writes. So all those requests are overrunning the buffers and causing the deferred write threshold to be hit. Okay, automated assessments of log related metrics are also helpful, can also be helpful. And here again, we see a number of assessments. So here again, for that same queue manager, there is an exception for waiting for log writes that are waiting for an available buffer. So again, let's kind of look at these metrics over the time interval. And again, we can see a high volume of that occurring in these early morning hours. So again, what would come to mind is we'd like to kind of see how that might, how that correlates to the log, how much log data is being written. So again, we pull that together on the same chart, and we see again that very expected, those weights correspond to a time when there's a much higher volume of log data being written than the most of the rest of the day. So I think the comment box from the earlier mouse over suggested that maybe looking at disk performance could be one consideration there, but maybe with that volume, it's tough anyway. So anyway, we'll go ahead and capture that in the dashboard. All right, there was another exception that was identified here for that queue manager, and that is the number of checkpoints that are being issued. And one reason for having frequent checkpoints may be that the log files are too small. So this might, let's go ahead and again, look at this, and let's look at this kind of over a broader time interval. Most of these I'm just looking at one day, but let's go ahead and look at this over a little, see the profile over a longer time interval. And this particular view, the green line's the average, the green bars are the 10th and 90th percentiles. You basically throw out the 3 lowest and the 3 highest days, and then the yellow bars are the min and max. So we can see here that it's very common over this month that we've got 100 or more checkpoints occurring during each 15-minute interval. And so queue managers that have been in production for many years are often still using kind of old allocation recommendations in the installation documentation, which were actually designed for test systems. And then also just a note, as of MQ version 9, the checkpoint count includes those from log switching as well as hitting log load. So sites with high checkpoint frequencies may want to revisit their log file sizes, as we mentioned. All right, just going to mention a quick case study here with actual data from a site that experienced a significant slowdown in their online transaction processing on a given day around noon. And they, MQ played a key role in their architecture, but they didn't have visibility and very much visibility into their MQ SMF data. So here's again those kind of health assessments for their buffer pool metrics, and we can see for that MQ E1 queue manager, that was again their high volume queue manager. There were exceptions for the number of times MQ was having to read data from disk because it had been flushed out of buffers. So then drilling into that in terms of which buffer pools, it was actually occurring buffer pool 0, which, as you know, is typically devoted to performance critical system related messages, and thus is maybe particularly sensitive. And so there's the exceptions for buffer pool 0, and then putting them on a chart together again showed lots of hitting the deferred write threshold many times and having to read many messages in from disk, and both those metrics spiked in that noon time frame when their outage occurred. So that indicates a possible correlation to the slowdown that they experienced. All right, so now let's go ahead and just look at some other statistics data. Said the MQ message manager is going to put out volumes of requests by the different types of MQ commands. And so here's the volume of MQ puts by queue manager. So this type of a view, you see kind of what the overall volume is, which queue managers have the most activity, a time of day profile, and so on. And so that can be a good starting point for developing a workload baseline, and also to indicate, significant performance changes. So, and this, as here's the case here, right? There's a big spike in the puts during this time interval. So let me just go ahead and broaden out the time interval just to see if that's a common thing or not. When we look at the entire week, we see that was indeed an anomaly, was an unusually high value there. So let me go ahead and add that to the dashboard. So that's about as far as you can go with this with the statistics data, but we'll come back and see how the accounting data can help shed light on what drove this spike. One other thing we might be interested in here as we look at the puts is to see how they compare to the number of gets. And other than at the time of that spike, there's a pretty consistent relationship with quite a few more gets than puts. And so that might indicate multiple queue managers competing to get the messages. So let's go ahead and capture that as well. All right, so as with DB2, well-performing MQ logging infrastructure is essential to supporting recovery and backout and without impacting ongoing performance. So logging activity is primarily driven by puts and gets for persistent messages. Unfortunately, those represent a minority of total messages in most environments. Metrics on the volume and the drivers of persistent messages are captured in the MQ accounting data, as we'll see later. So we touched a little bit earlier on the weights for available buffers. So let's go ahead and look at that a little more closely. First, let's look at the log data itself. Gonna again just kind of look at it over time to see what the patterns are like. All right, and when we do that, we can see again that spike in the early morning hours in terms of the volume of log data written is occurs very regularly. So now let's just occurred to me that it'd be interesting to compare that volume of log data with the number of log write IOs. So again, I'm going to just put those both together here. And again, interesting here, you see a pretty consistent relationship through most of the day. And if you take these numbers off to the side and do a little math, it's about 5K of data being written per log write request for most of the day. But in this early morning hours, you see a big switch on that. And then the number increases to 68K per IO. So again, in this case, I don't have accounting data for this site to be able to research that further, which I wish I'd be able to do. All right, and then one more area, we'll look at buffer manager metrics. Again, we talked earlier that there was kind of a spike in deferred write thresholds that we saw here. Let's look at, again, that high volume queue manager. And again, look at the profile over time. So earlier when we looked at this, there was a spike around 8 p.m., but we can see that's really represents kind of an exception, that normally the volume is less than 1/10 of that. One other area of interest is, again, when MQ has to read messages from disk, of course, that's going to take way longer, and that can be a factor in slowdowns. So again, one more time, if we look at the profile of that metric, there we go. we'll see that actually that spikes up much higher in the early morning hours. So again, that 8 p.m. situation we saw earlier was kind of an anomaly, and actually the point of contention in this environment typically is in those early morning hours, when we also saw the high logging volume. All right. Okay, so that's kind of a little brief journey we took through the MQ statistics data, just kind of remind ourselves where we've been. We saw the deferred write threshold metric and how it correlated to buffer utilization in the logging, waits for available buffer occurring, and how that corresponded to log megabytes being written. A surge in puts for this environment. We're looking forward to looking at the accounting data to help us understand what was driving that. Again, the puts and gets in this environment and the relationship between the two. Here again, the relationship between the megabytes written and the write IO request, which is pretty consistent throughout much of the day, but in those early morning hours switches back. And then the fact that the reading from disk operations is happening pretty heavily on a consistent basis in those early morning hours. All right, so now let's transition over to the accounting data and see what we can learn there. The SMF 116 accounting records, they have detailed task level data. Most of the accounting data is only generated when class 3 is specified on the start trace accounting command. If someone specifies that start trace command but doesn't specify class 3, then by default you just get the class 1 data, which is a very limited set of metrics. So gaining value from what's typically massive data sources is often achieved through focusing the analysis on a subset of the data. So here's a list of many of the levels at which the accounting data can be viewed, or ways that it can be subsetted. One common line of analysis is activity for specific queues, including like the depth of messages on a queue or the time messages spent on a queue. Another common focus for MQ accounting data, as is also the case with DB2, is by connection type. Who's the caller, right? Because the profile of work coming from CICS may differ, for example, from the channel initiator work. And so the remaining items in that second column indicate more ways that the accounting data can be subdivided, typically after you've initially gone by connection type. The availability of those additional levels of detail differ by connection type. For batch and TSO callers, the data, you can also view the accounting data by address space name. The channel initiator work can be viewed by the CHIN address space name, as well as the channel name and channel IP address. In addition to region name, you'll likely want to view the MQ work coming from CICS by transaction ID, and we'll do that a few times in the demo. Command server work can be viewed by queue manager, and work coming from IMS can be viewed by IMS subsystem name, and also by program specification block PSB, which often provides an application-oriented view. And for reference, here's a sampling of some of the kinds of metrics that are available in the accounting data. But rather than talking about these, let's look at examples of from specific data. All right. All right, one area which accounting data, as we mentioned, provides insights is on activity by queue. So here's an example of command rates by queue. And so in this environment, we see that a very sizable percentage of the MQ activity is operating on these two standard name queues. And we can see for the cluster transmission queue, opens, closes, and puts. And for the channel status queue, a pretty even distribution of gets and puts. So you can also view a CPU, MQ CPU usage from the accounting data. And again, here in this particular environment, it's pretty much concentrated on those two queues. Certainly in other environments, I've seen CPU and MQ command activity more widely distributed across many queues. So in addition to queue name, another common way to view the MQ activity is by the type of caller or connection type. And again, that's also a common way you want to subset DB2 accounting data as well. So here we see that the CPU going on within MQ is coming almost into is being driven almost entirely from CICS and from IMS for this particular queue. Yeah, and we'll come back and view other queue level metrics later. All right, so now let's work from some high-level views that begin by a connection type. So in this environment overall, that previous view was just for that one queue. In this environment overall, there's three primary drivers of MQ CPU: channel initiator, CICS, and IMS. As mentioned in the slides, accounting data captures the CICS transaction ID so that you can view the MQ CPU generated by each transaction. So viewing this particular CPU that's generated from that particular transaction over time kind of shows a decreasing amount of CPU over the particular interval that's here. And if we, just compare that to some other time interval earlier in the week, we see a similar profile. Oh, I'm sorry. I clicked 2 weeks earlier because I only have a week's worth of data in the database, my test database, my bad. Anyway, okay, so we can see that's a pretty representative profile. Okay, and again, here we're going to create a dashboard to kind of just collect some of the views that we view here in our learning journey today. All right, if we look at that CPU, again, by type, and not much batch CPU, but when we look at it, we can drill in by connection name, or in this case, that is gives you the job. So if a site's interested to see how much MQ CPU is driven by which jobs or which address spaces, then that data here is available in the accounting data as well. So let's go ahead and capture that as well. All right, so in our earlier journey of MQ statistics, we encountered this spike in puts on this particular queue manager. So we couldn't go further with the statistics data, but now we can see how the accounting data can maybe help shed light on what drove that spike. So this particular site is only generating the class 1 data that comes by default when you do that start trace command, not the class 3 data. But in this case, that's still going to be sufficient to provide helpful insights here. Okay, so we're going to focus on the puts. So let me just focus on those, and also it was the high volume queue manager that occurred. So we'll just put a filter in here that only grabs data from that queue manager. All right, so here we see that spike during that period of time. So again, now that we have access to the accounting data, we might likely want to start by viewing this data by connection type, which again, the accounting data, even the class 1 data gives us. And when we do that, we see that the spike was driven from MQ activity coming from batch, or TSO. So now let's take it one more. We said earlier too, right? If for that kind of work, the connection name then is going to give you the address space name or the job name. So let's go ahead and only look at that connection type. And now let's look at it by connection name. And there's going to be a lot of entries there. So I'm going to limit this to the top 5 address spaces that are doing the most puts. Okay, and then when I do that, now I see that this particular job at that particular time was responsible for generating, over 10,000 messages a second during that interval. So that's the job that drove that spike. So again, I could see the spike in the statistics data, but I needed the accounting data to be able to see, what drove it, right? And in this case, the class 1 data was enough to answer that question. And for many other types of questions, you will need you'll need the class 3 data. Okay, now back to an environment where there is class 3 data. There's another available metric is elapsed time. So here's a view of total time by, well, this view is of total time by MQ command. And later we'll come back and look at elapsed time per command, per issuing of like the get or the put later. This is the total CPU for the different types of MQ commands in aggregate. Okay, another way that you can view the accounting data is by buffer pool. So one use case for this could be if you're experiencing an unexpectedly high level of utilization and activity in a specific buffer pool. So you might want to ask, okay, well, what queue is involved in a whole bunch of those messages? That might be one question that you'd ask. Or again, you might ask, well, which type of caller is driving the messages in that buffer pool? So again, there's just another way you can look at the data. Let's go ahead and grab hold of that one. Okay, the accounting data also captures elapsed time that's broken out across many MQ components. Here, for example, for the channel initiator work, you can see these different types of components. For the KICS work, again, there's not as much elapsed time, but again, you can view it by transaction and see that for most of the KICS transactions, the suspend time, the journal write, prepare, and commit times are the contributors to the total elapsed time. Let's go ahead and hang on to that one in our dashboard. Okay, the accounting data also captures elapsed time for the latches that are the 30+ latches that are used within MQ. So that might come into play for a specialized analysis, but for time today, we'll not go there. Okay, we talked about looking at CPU per MQ command. So here's CPU per get. So when we view that in this environment by connection type, we can see that the CPU per get is a bit higher for the work coming from IMS than it is from the other callers. So let's go ahead and look at that. We mentioned earlier that one of the ways you can view the IMS data is by PSB name, which is sort of has an application flavor to it. Again, there's a lot of those. So let's, again, limit that to the top callers, MQ get callers. And so we do that. We get kind of an application view now of the CPU per get in this environment. There's not much difference between the various applications there. So let's go ahead and grab that one. Okay, and so that was CPU per get. We might also be interested in elapsed time per get. And here again, we see we see a spike in the elapsed time. I mean, these are not long times to be sure, but we see a spike in the work coming in from IMS. So again, this might be a time where we want to look at it by application, PSB name. And again, lots of noise there. So again, let's do the top get activity, top get callers. All right, when we do that, we see that this particular PSB had much higher elapsed times per get than the rest of the work. And so that was likely the driver of the spike we just observed. Go ahead and grab that in the dashboard. Okay, in addition, the accounting data has reports on message lengths, and it does that in a couple of different ways. One way is by buckets. It groups the lengths into under 100, under 1,000, under 10K, and over 10K. So here, when we compare the profiles, we see that almost all the IMS work is under 1,000 bytes, whereas there's a good portion of the KICS work that's between 1 and 10,000 bytes in terms of message lengths. And again, if we want to look at that across the KICS transaction, we can see that most of the long messages are coming from these two KICS transactions. Again, if we look at that for that transaction, and let's look at this as a line chart. When we do that, we can see that the volume of messages, both the under 1K and the 1 to 10K message, and the volume of messages is declining over the interval. And again, this was the transaction we saw earlier that the CPU always declined over the interval. So that explains the reason for that as well. Let's go ahead and hang on to that one in our dashboard. Okay, so in addition to those distributions, MQ also captures the minimum and maximum message lengths. So, here, for example, we see a pretty consistent maximum message length for IMS around 70K. The KICS data, the messages, the maximum messages kind of jump around. So again, we can see, which KICS transactions are generating the longer messages. The accounting data also has queue depth information. So this initially here, we're starting out by connection type, but we're probably going to want to look at this by queue name. So let's look at that for the KICS data by queue. So the KICS work typically has a pretty deep messages in this delete queue. We could look at that and see that it's widely used by many transactions, but for time, won't go there. We see this spike when this queue where there's a lot of messages where there normally isn't. And so again, if we want to look at that, we can see which transaction encountered that abnormal length of messages on that queue. Also, the accounting data captures the maximum time on the queue, actually maximum, minimum, and total elapsed time from which you could calculate an average. So here in this environment, the channel initiator spends a huge amount of time on the queue. So let's remove that. And then when we look at the other callers, we see there were a couple of spikes in terms of messages spending a really long time on the queue. And again, we said for batch and TSO work, you can drill into that and find job names. And so there was a set of messages here. The dot kind of hides the other messages behind jobs behind there, but there's actually a set of 6 jobs here that encountered those deep queues, or had the long message on the queue at 10 a.m. and 2 p.m. And then just a brief mention, there's coupling facility metrics that support shared queues for MQ. As you would expect, and from the data that we've seen so far, you can report on the coupling facility data by queue name, and you can also report on it by connection type. But in addition, there's CPU specific metrics that are in the accounting data. So this is the volume of requests by queue, but now they're broken out by synchronous and asynchronous coupling facility messages. Go ahead and hang on to that one. We can also look at data by coupling facility structure name. So the persist and non-persist are commonly used structure names here. And again, if we wanted to, we could see, well, which queue had the persistent messages, or which we could also look at it by connection types. So the accounting data can answer those kinds of questions. All right, so again, just to briefly remind ourselves on the journey we've been, we looked at CPU usage for this KIX transaction declining over time. We saw which batch jobs or address spaces were using the most CPU. We could explore the data by buffer pool. There was, accounting data shows you which components of MQ the elapsed time is being spent. This was CPU per get, and we saw pretty consistent across the IMS applications. This is elapsed time per get, and we saw a particular application that had a longer value there. This transaction had declining message volumes, but in some of the longer messages. And then we saw a spike here in that queue and which transaction encountered that, and finally a little bit about coupling facility data. All right, so I hope that our learning journey today that has expanded your horizons on the type of metrics that are found in the MQ statistics and accounting data, and it's piqued your interest to explore your own SMF data to gain insights into how MQ is operating in your environment. For more information on what you can learn from MQ SMF data, I'll point you to these two MQ articles in our Learning from SMF series in these 2020 issues of Cheryl Watson's tuning letter. And if you're not yet a subscriber of that, and I think you're missing out on a tremendous amount of very valuable information if you're not, but anyway, Frank and Cheryl kindly allow us to provide reprints of those articles, which you can request at that email address. And again, I used IntelliMagic Vision today as the tool for learning for statistics and accounting data. Again, this is just a brief slide for reference of how we deliver those capabilities to our customers. In general, people run that in our private cloud. They run their SMF utility data through a compression utility, FTP it to us, and then they type a URL in their web browser, and then off to the races to use the capabilities of the web reporter that you saw in this demo today. All right, so here's the request that Mel will remind us again at the end to submit your session feedback. Here's the slide on the charity raffle for GSE, and slide about becoming a member. And I think we've got a couple minutes left here for questions. Mel, have any questions come in?
No, not yet.
Okay.
If anybody wants to submit one, be quick.
Okay.
And thank you very much, Todd. That was very interesting. And that's quite a piece of software you got there.
Yeah.
Yeah,
and again,
oh,
I'm sorry.
Very good indeed.
Okay, yeah, and again, the kind of the overall, I guess, two takeaways I'd want to put out there. One is when you have good visibility through our tool or whatever tooling you have, if you have good visibility, you can learn so much about any component of the Z platform, right? And so today was our journey on MQ, but it's just, I just love to learn. And so that's, again, I am so happy that I get paid to do that. And so I hope this just encourages you to go back home, look at your SMF data and see what you can learn from it as well.
Okay, thank you, Todd.
Okay, thank you for attending.
Yeah, the next MQ session is at midday tomorrow. So look forward to having you attend there. Okay, thank you very much, Todd.
Thank you. Goodbye.